Hi everyone, time for another video. This is going to be the first of two videos to wrap up our exceptions to the rule concerning genetics. We're getting close to the end of genetics. We've got probably these two videos and then probably one, maybe two more after this. My goal is to get through them all this week so that we can start new stuff after April vacation. So today, first thing we're going to be talking about are sex-linked traits. Now, sex-linked traits are traits that are carried on the X or Y chromosomes. Remember the 23rd chromosomes, when we look at those karyotypes, determine biologically if you are going to be determined to be male or female. If you have two copies of the X, you're female. If you have XY, you're male. And remember, it's the male that determines the offspring's sex, because 50% of his sperm have this Y, 50% have this X. That's going to be very important in a moment. So certain traits are carried on these chromosomes, just like they're carried on the other 23 chromosomes. Traits that are carried on the Y chromosome are obviously then only passed from father to male offspring. They can't be passed any other way. And there aren't a lot of traits that are actually carried on the Y chromosome, so we're not going to really worry about that, although that would be a sex-linked trait. Instead, we're going to talk today about traits that are carried on the X chromosome. Okay, so remember, when a female and a male reproduce, there's a 50-50 chance that the female will pass on this X, 50-50 with this X. With the male, it's 50-50 X or Y, and they produce either a female if they both pass on their X, or a male if the female passes on one of her X's and the male passes on her Y. So what if there are traits that are carried on the X chromosome that are passed to the male? What we have in sex-linked traits are a disproportionate likelihood of getting certain characteristics carried on the X chromosome in males. So here's an example. Let's say you have a trait that's carried on the X chromosome. I've indicated that with this little 1 or I, whatever you want to call it, right here next to the second X. This is recessive, all right? So this female does not display this trait. And let's say this trait is color blindness, because color blindness is a classic example of a sex-linked trait, okay? So color blindness, being unable to see red and green colors, is carried on the X chromosome. The female is not colorblind because she has this X, which cancels out this recessive allele. So it's like she's heterozygous. The male is also not colorblind. But when this pair produce a male offspring, there is a 50% chance that that male offspring will be colorblind. And that is why colorblindness is so much more common in males than in females. Because the father is going to give his Y. That's it. But there's a 50-50 chance if the mother gives this X, no color blindness. But if she gives this X, even though it's recessive, with only one copy of the X allele or the X chromosome, that means that offspring will automatically be colorblind because there's not another dominant chromosome or allele to cancel it out. All right, so that's why colorblindness or other sex-linked traits are so much more common in males. All right. Females can be carriers. Let's say this same pairing. In this case, if the mom passes on her X with the recessive colorblindness, the male, though, gives his X. They have a daughter. That daughter is not colorblind. All right, but she is a carrier for colorblindness. So she could then have a son that would have a higher likelihood of having colorblindness. All right. The only way you can get, say, a female with colorblindness is if the father himself is colorblind and the mother is at least a carrier for it. Because in this case, if this couple had a daughter, the mother has a 50-50 chance of passing on that marked chromosome with the recessive. The father, though, is going to automatically give his X. So whenever you have a male that's got color blindness, they're automatically going to pass on the carrier to their daughter, okay? But it's unlikely that he would pass on to the son because he's going to give the Y. All right. So it's disproportionate between males and females. That's what a sex-linked trait really means. It means that either males or females are more likely to get a specific trait, depending on whether they have an XX or an XY combination of chromosomes. The two classic examples of this are colorblindness and hemophilia. These are both sex-linked recessive traits. They occur much more frequently in males than in females. All right, that's it. Now let's go on to the second video.